What's up? What's up? What's up? It's your boy, the network. And today's topic is Section 3.9, Configure and Verify Filtering with Any Protocol. This is a topic in the CCNP route exam code 300-101, version 2.0. Let's head over to the blueprint to take a look at where we came from and where we are headed. All right, it's the exam blueprint, implementing Cisco IP routing, exam code 300-101, version 2.0. Make sure you are studying for the most up-to-date material, and you should be able to tell by looking at the blueprints and the date of your literature. We just wrapped up. Just remember, I think this version came out, I believe, in 2014, if I'm not mistaken. Maybe 2015. Maybe, I'm not too sure. But anyways, we just wrapped up the Configure and Verify VRF Lite, which was that wasn't really tough. It just, I just didn't really practice it before I recorded it. Today, again, we are doing Configure and Verifying Filtering with Any Protocol. And after that, we're going to do Configure and Verify Redistribution between any routing protocols or routing sources. Again, today we are doing Verifying Filtering. So filtering, what is it? It is basically what it is. You are filtering routes, right? So with the route exam, we know we mostly talk about routing protocols, OSPF, BGP, EIGRP, and these routing protocols, what do they do? They make the routers become neighbors, and then they make them exchange routes, right? Well, we might not want all of our routes to be exchanged, right? So we want to block some of these routes, and that's where route filtering comes in. There's several ways to do it. We're going to go through these slides, and I'm going to show you how to do it. I'm going to go spin up GNS3 Lab, and we're going to show you how to do it. Let's head over to the slides for some more material and the official definition. All right, so before we head over to look over to the definition, you took a look at this image right here. Y'all know I'm going to put some images and movie clips and stuff in my videos now. Just think of route filtering. You remember this, back in I don't know how old you guys are, but back in my early, 20s, and when I was starting to go into clubs and stuff like that, you always had the bouncer, especially at the nicer clubs, the bouncer at the club that's going to let some people in. I'm in the Orlando, Florida area. There's not too many clubs that do this, but the big cities, New York, LA, Atlanta, and stuff like that, Chicago, they usually have these clubs that you got to dress to impress, right? Or they just might look at you and be like, oh, you ain't got no females. They going to block. They going to look at your clothes. They're going to stop you from coming in. But think of route filtering as the bouncer, right? But the bouncer doesn't just filter people from coming in, right? He actually creates a fire hazard when we're talking about route filtering, because he can also stop people from coming out of the club as well. So he's stopping people from coming out of the club, and he's also being selective with people coming into the club as well. So again, when we think about route filtering, think of the bouncer allowing people to come in and out of the club, right? Official definition, right? In the context of network routing, not nightclubs and bouncers, route filtering is the process by which certain routes are not considered for inclusion in the local route database. Looking at you, nah, you can't come in, man. We don't like them shoes or them pants. Polka dots, nah. Or not advertised to one's neighbors. Route filtering is particularly important for the Border Gateway Protocol, BGP, on the global internet. That is the main routing protocol that is used on the internet, if you don't know by now, where it is used for a variety of reasons. One way of doing route filtering with external resources in practice is using route policy specification language in combination with internet routing registry databases. That was a mouthful, and I believe I got that from Wikipedia as well. But anyways, that's just a basic definition of route filtering. Again, we use this to be selective with what routes we want to share between our routing protocols or between our routers. We could do this redistributing EIGRP with a RIP route, or vice versa, or OSPF with a BGP route, and select certain routes that we want to share. Now, the reason why we want to do this, main reason why, is because of network performance, right? Routing factors that include CPU utilization, right? If you think about OSPF, for example, OSPF, we've talked about this multiple times. It uses an algorithm called the SPF algorithm, which stands for shortest path first. Say that 5 times. Also known as the Dijkstra algorithm. And it uses this like mathematical computation to figure out different routes and stuff like that, right? If it does that too much, or if it has too many routes, it uses a lot of the CPU. So that, again, it affects CPU utilization. The size of the routing information update, the frequency of how many times you get updates, the weaknesses in the design, the presence of any route maps or filters. Route maps, we're going to be covering that in, I believe, section 3.17, something like that. Incorrectly configured route filters, these all, affect network performance. So when you have large routing tables, route filters can allow us to minimize these routes or just, make them smaller so that way we're not using too much of the CPU. We don't want to stress our CPU, the CPU of our routers. Running different protocols in different areas within the same autonomous system. But if you look at this right here, this network right here, let's say this is an OSPF network. You got all these routes. You got the 10.11 route. We got the 10.10, 10.13, 10.14. If all these routes, if something goes down, right, everybody gonna get an update. Then they gotta recalculate and stuff like that. You're gonna get a lot of CPU utilization spikes. So that's where route filtering will come in, because we'll be able to minimize our routing tables, make them not so long, and use up too much of the CPU. This is especially important with OSPF. Filtering routing updates. Routing updates may improve network performance, as we said, by making the routing table smaller. Ensure that route filters are configured correctly. If you look at this this image right here, we got a multi-client home, we got a primary link and a backup link. Right here, primary, backup. We got that primary router here, the backup right here. Once we do if we do an incoming filter, we will place it right here. So any kind of updates that come into our router right here, we will be filtering them by using prefix list. I'll show you the configuration in a bit. Running multiple routing protocols. You can run different protocols in different areas within the same AS. If you don't know by now, if many routing protocol processes receive updates at the same time, performance will be affected. You look at this multicolored clouds right here. You got EIGRP, you got OSPF, you got BGP. You got somebody with a network that's got all kind of routing protocols going on, and they calculate routes differently. This can, again, diminish your network performance by having to calculate different routes and stuff like that. Filtering can help reduce this problem. Controlling routing updates. There's several ways we can do it. The latter half at the bottom is what we're going to really focus on, minus the route maps, because that's a totally different objective in the exam. Routing updates are critical, but compete with user data for bandwidth and router resources to ensure that network. I'm not going to read all this to y'all, but basically, there's 3 different ways that you can control routing updates. Passive interfaces, which we've talked about, I believe, in 2 videos back. Default routes, we talked about that a couple videos back. It can eliminate the need for other routes. If you just have a default route, I don't know how to get somewhere, let's just take this road to get out of our neighborhood. You do that and not have any other routes, that minimize your routing table. Static routes can also do that, can limit or eliminate the need for dynamically learned routes or give greater control for specific routes. So static routes, again, you have lower administrative distances when you do it. They're reliable routes because you put them in. So this is a route that it's static. It's not going to change. It's not, that's what the word static means. Again, we are going to be covering advanced route filtering. These would be considered advanced route filtering techniques. These would be kind of like simpler techniques because they just like 1 or 2 commands, really. These are a little bit more complex. You can get real creative with these ways of filtering routes. Route maps, which again we're going to cover in I believe 3.17, I don't remember. Distribute lists, which we're going to cover today, and prefix lists, which I believe we're going to cover that today as well. Using route filter. A neighbor relationship is established, right? You got, let's say, this router right here, and he becomes a neighbor with another EIGRP router, right? Adjacent routes exchange routing updates, as we've mentioned. So once we become neighbors, we exchange routes, right? If you have a route filter, it goes through this process right here. If you look at this flow chart, first, let's say we got a routing update from our neighbor. He's an EIGRP neighbor, right? Comes in, it determines which interface is going to come in, right? Let's say it comes into our serial interface, right? First thing the router is going to do is determine, is there a filter for this interface? If not, then it's going to process the packet normally and just send it on its way through. If there is a filter, it's going to say, the bouncer again. Think of this as the bouncer. There is a filter for this interface. He ain't got the right clothes on, or he just doesn't match an access control list, an ACL. We're going to go over that as well. Is there an entry for this address? That's basically he looking at his RSVP list. Your name ain't on this list. So if not, no, he gonna drop the packet. You get out of this line. You ain't coming to this club. I'm not wearing that. If there is an entry for this address, then we're gonna process the entry according to the filter configuration. There's so many ways to configure the filter. We just not gonna name it all here, but it'll just process it like, okay, well, we get this route. That means you just look at the configuration. There's so many ways to do it. Again, we can be really creative on what to let in and what to let out. So it's just like the bouncer. He got a list of who can come in and who can't come in. He got a dress code of who can come in and cannot come in. So that's equivalent to, okay, we got an access control list. These type of addresses matching this can't come in. Or he has a prefix list that says, okay, deny anything that got these type of addresses above this type of subnet mask. We'll go over that. That's the same thing as, okay, you can't let nobody in that got polka dots, or I don't know what I got against polka dots, but you just can't let nobody in wearing that. There's 3 ways to use distribute lists, right? You can configure an ACL, which is a CCNA topic. You can configure a route map. We're going to cover that in section 3.14, like I said multiple times, or configure a prefix list, which we're going to cover today. What you would do is configure the distribute list to use the ACL or route map, or really prefix list, which a prefix list is just like an advanced version of an ACL applied to the inbound or outbound updates. And you could choose if you want to apply this filter on every interface, or you could choose specific interfaces that you want to apply these filters to, just like access control lists. If you look at this picture right here, you got router 1, router 2, and this is just basically the filter, or the bouncer at the nightclub. Here's a distribute list and ACL example. This is just written example. We'll go spin up GNS3. I'll show y'all another example. So first thing you're gonna do is create the access list. IP access list in blue, right? This is a standard access list. I'm gonna do an access list different way. I'm not gonna use the IP access. I'll just use regular access list, and then name the route filter. Right? In this case, it's just route dash filter. How creative was that? Create a remark, or that's like a description, and then you're gonna say, permit this, and then permit that. Exit. Then you go to the router config mode. Choose the routing process. You could redistribute, which we haven't gone over yet. That's basically if you want to do OSPF to EIGRP or vice versa, or any other routing protocols. The important part here that we're gonna cover today is this right here in blue, distribute list. So once you do that access control list, saying what does it do, you use distribute list to distribute either that access control list or that prefix list or that route map, which we're gonna cover in another video. How times gonna say that, and then you name it. In this case, route filter. Well, you're not naming it. You just referencing the name of the access list. You'll see, once you do like question mark, you can see what you could distribute. In this case, we are distributing an access control list right here. And then choose the direction, out or inbound. In this case, we choose an outbound. So we're filtering what we're going to send out to our neighbors. And then you choose the the routing protocol, and then the process of the routing protocol. Now, this is only outbound that you could do by protocol. Inbound, you can only block certain routes, not necessarily by routing protocol, because you really don't, well, you do know where it's coming from, but you can't block by routing protocol, I don't think. You look here at the bottom, router 3 must redistribute. This is basically saying router 3 must redistribute EIGRP routes into the OSPF domain with a metric of 40. And that's what this is saying right here. Only permit, right here in the blue, the 10, 10, 11, and the 10, 10, 12 routes to be propagated. So we're only going to give these routes, basically. That's what he's saying. Router 2 is only going to share those routes. Anything else, deny, because remember, it's just like an access control list. There's an implicit deny at the end. You're just, basically, you do not bouncer at the nightclub. You like, all girls get in free. So you implying that the men don't get in for free. That's basically what you do. That's basically what you're doing with the access control list. If you don't specifically say who you're not letting in, you just implying that you're denying the others.
Hey, look, I don't make the rules.
Please.
No. Hey, what's up, shorty? What's up, pretty girls? See y'all when y'all get out.
Let's go ahead and fire up GNS3 and go over distribute lists with an ACL. All right, simple topology I got right here. We got router 1 on the left-hand side, router 2 on the right-hand side, right? Router 2 has all of these right here, loopbacks configured on him, right? So he's got both of these routers are neighbors. They're participating in router EIG process number 1, I believe it is. Yeah, process 1, right? So router 2, he's going to be sharing these routes with router 1. Router 1 is just going to be filtering which ones he want to know. So let's go ahead and console into router 1. Let's go ahead and take a look at his routes so far, right? He is learning all these routes from just pretty much one interface, right? Fast Ethernet 00, right? This is the 192.168.12 network. This is the 172 routes, right? Show IP route, not plural. And as you can see, there's all the loopbacks that he learned through, right? EIGRP. Pop quiz. Why did they not make EIGRP just E in the legend? If you know the answer to that, put it in the comments below. So those are the routes right there, right? Let's go ahead and create an access list. And let's block out lucky number. Let's block out number the 16.4.0 network. That's my favorite number. Let's go ahead and create an access list to block that. First, let's configure terminal IP. Actually, let's just do access list. We're gonna give it access list number 1. Actually, access number 5. We're gonna deny the 4 routes, which is 172.16.4.0, right? And then we got to do, I believe, the wildcard mask. That's the reason why I don't really like playing with ACLs. I don't know about y'all, but I kind of struggled with that when I was studying for CCNA. This should be easy. So 000.255, right? And then after that, we're not going to log any entries because I don't want to make this too messy. So we created that access list, right? Let's go ahead and create. We need to also specify, we're saying we're denying this. But remember, there's an implicit deny at the end. So basically, we're saying deny this, deny everything else. We need to say who we're permitting, right? That's a basic access control list fundamental. So we're going to do access control list number 5 and say who we're permitting. We're permitting anything else. So basically we're saying block this guy, let everybody else in, right? Let's block this dude right here. Y'all can come in, but you can't come in, bro. Any, right? So now once you've created your access control list rules, ACL rules, you will distribute the list. This is where I had difficulties with. I didn't realize, well, not when I was doing ACLs, but when I was working with prefix lists, which we might do in another video. So you go to router config mode. It's EIGRP 1 in this case. And then you do distribute list. And I'm going to show y'all what options you got, right? If I could type here, distribute list, right? You choose the access control list number that you're going to refer to, which in this case will be 5. Or you make a name. You can create the name. Remember, you can name access control lists. Gateway, not too sure what that is, but I'm going to look it up and I'll put it in the link below. Prefix, you could do by filtering prefixes, which we may do in this video or next video. Route maps, that's going to be in section 3.14. So that's what you can reference. In this case, we're referencing ACL number 5. And then we're going to filter incoming updates, right? Because these updates are going to be coming in from router 2 to router 1. If you want, you could do outbound, but that won't make any sense because he has nothing he's going to be advertising that he don't know about. He know about this from network, but he's connected to it. He's connected to it already. So he don't have nothing else that he need to know from router 1. In this case, inbound, and then you can choose which interface, which in this case, there's only one interface you're going to be receiving them from. Or if you just leave it blank, you're saying every interface I want to apply this filter to. Let's just leave it blank and do every interface, right? And now we could, let's run a show command and see what we got so far. Do show access control list. Let's do access list, right? And then this is what we got so far. And notice EIGRP just resynced, right? Because basically when we did this, when we applied this distribute list, that basically kind of like, it's kind of like it activates or applies the access control list. And that's what we got this message right here for. When we did this show command, that basically that's a basic show command that you should know about ACLs. You're saying what that ACL does. So now if we do a show IP route, you should see we have essentially blocked the 4 routes, right? It was in here. It's no longer in there, right? So let's go ahead and remove those and try another one real quick. So now we're starting from scratch again, right? Clean slate. Let's take a look at our routing table again, right? That is one way you could, basically filter your route, right? But we filtered only one route right there. Let's say we want to minimize this table. Right now we've got what? We've got this connected route here, which don't really want to really count. We got this network, the 172.16 network. Let's say we want to get rid of it. Like we got 1, 2, 3, 4, 5. So if anything happens, we've got, this could use up a lot of our, routing our CPU. If you have hundreds of routes, if one change happens, it could spike your CPU. So let's filter it down to just one route, right? Let's allow just the 210 route. Let's say let's do it by access control list again, right? Access control list. We're gonna give it control list number 15, right? And then we're going to say we're going to permit that rule, right? Or this network right here. We're just going to permit that network. It was /16, so that means the wildcard mask should be 00.255.255, and we don't want to log any entries. I don't want to make it messy. That's who we're permitting, right? Do we need to put any denies there? No, because there's an implicit deny at the end of access control list, right? So we don't really need to do that right now. We're permitting him. That means we're saying, okay, y'all can come in. Since I ain't look at them, they should already know that they can't come in, right? So let's verify that. Do show access control list and see what we got so far, right? That's our rule so far. Let's go ahead and apply that rule, right? Again, distribute. No, we got to go to router config mode. I'll be forgetting that. EIGRP 1, distribute list. So remember, access control list and then distribute list. That's how I would try to remember it. So you choose what you want to create and then you distribute it. In this case, distribute list number what? We're referring to access control list number 5. So let me show y'all again. You can put a number for an access control list, a word if you named it, gateway. Again, I'll put a link in the description below on what that is. You can do by prefix or route map. Route map, we'll cover that in another video. Distribute list number, not 5, I'm sorry. 15 we named it, right? We're going to apply it to incoming updates since these updates are going to be coming inbound on this interface. You do that, you should see EIGRP resync whenever it feels like it. Watching paint dry here. And there you go. And then we can verify that by doing do show IP route. And we've essentially minimized our routing table to just one route. Let's do one more. All right, so I removed those routes. Now let's just do one more, and then we're gonna cut it short and do prefix lists in the next video. Let's keep the 16.1.0 route and the 16.2 route and deny everything else, right? So it's kind of like we cutting the middle of the pie and cutting everybody else out, right? We picked the fine girls right in the middle of this line, and we said the rest of y'all gotta go. Okay, so basically you just adding them, you just basically doing an access control list for each one, really. So let's do access list. Let's do access list 20, and then choose, let's say we're gonna permit 172, right? Because we're permitting them in, right? We letting the fine ones in. 16.2.0 1.0 quad wildcard mask is gonna be 000 255, and we not gonna log any entries on that. And then we're just gonna create one more permit. So same control list, so that way we can just refer to one. Permit 172.16.2.0. Same wildcard mask, which is for /24, it's 000.255, right? So we're permitting those two in. Guess what? If we don't say anything else, we're implying everybody else is denied, right? Now we're gonna distribute this access control list. Distribute. Actually, we gotta go. See, I keep forgetting. Go into router config mode when you do this. Router config, router EIGRP 1 in this case. It could, if it's OSPF, you do router OSPF process number, whatever. This one, in this case, it's AS number 1 for EIGRP. And then you distribute the list. Remember, refer to the access control list. In this case, it is number 20. What are we gonna do? Where are we gonna apply it? Inbound. Let's do it differently and just specify the where we are going to be filtering these routes. In this case, we're going to specify it on this interface, FA00. So FA0/0. Wait till EIGRP syncs. And there you go. Now we do a show IP route. You can see we've only allowed the 1 and the 2 route. Everything else has been denied. So we will cover prefix lists in the next video because I don't want to try. I want to try to keep these videos Short as possible. I did a little too much theory in this one. So if you like this video, please comment, like, subscribe. Make sure you hit that notification bell so that way you join the notification gang. That way you know when I'm uploading these new videos. Again, please like, subscribe to the network.